Okay, so hopefully everyone's on that is going to get on. 11 of you, that's not too bad. So we're doing distance between points today, which means that we're going to have 2 points on a graph, and we're going to have to calculate the distance between them as if we were walking between the two of them, okay? So let's start with an example. I have 2 points. I have point A, which is at 6, 4, and I have point B, which is at -3, -4. So the first thing I'm going to have to do when I have 2 points is I'm going to need to graph them to figure out how to find that distance between them. So I draw my nice pretty coordinate plane. I went about 6 in each direction. I'll give you guys a second to draw that. And then we will refresh how to graph a rectangular point on this coordinate plane, because I think we could use the refresher. Okay, hopefully at this point you've all had a chance to draw this coordinate plane. So the first thing I'm going to do is I'm going to plot point A, which is at the coordinates 6, 4. So from 0, 0 here, which is where my axes cross, I'm going to move right 6, and then I'm going to move up 4. And that's where I'm going to put point A. I'm going to do the same thing then with point B. From 0, 0, it's a -3, so I'm going to go left 3, and then I'm going to go down 4. And that's going to be point B. I'm not an art teacher, so I'm not looking for these points to be absolutely 100% perfect, but I should be able to tell approximately where they're at, okay? So now comes the fun part. How do I find the distance between these 2 points? Well, first I need to count the horizontal and the vertical distance. So imagine that we were walking in a town and we had to walk along the city blocks. We couldn't cut across anybody's yard. That's going to help us decide the diagonal distance. So from point B to point A, if I would like to travel that direction, I would have to go 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks to the right from point B to get in line with point A. And then I'm going to count my vertical distance. So from Y is -4, which is where I came out, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So then my vertical distance here is 8. What is this starting to look like to some of you?
Slope?
Not a slope. How about a right triangle? Right? So I have my 2 legs, and then if I were to connect the 2 points that I plotted, I would have my hypotenuse. So in the end, I would like to calculate the straight line distance between my 2 points, but to do that, I have to find the legs, and I need to plug them into the Pythagorean theorem. So in case some of you can't remember, the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the 2 shorter legs of my triangle, and c is the hypotenuse, which is what we're going to be solving for. Okay, so we're going to say this one's a and that one's b. So I'm going to go ahead and plug in those smaller leg values. So the distances horizontally and vertically. A here is 9, so I'm going to have 9 squared plus b was 8, so 8 squared, equals c squared. I don't know what c is, so that's what I'm going to be solving for. We have calculators, so we can easily calculate 9 squared and 8 squared. 9 squared is 81. 8 squared is 64. C squared just stays C squared. I can put 81 and 64 together. When I do that, I get 145. Again, I'm trying to solve for C. Right now I have C squared. So the only way to get rid of a square is to square root both sides. So when I do that, I get C is equal to the square root of 145. And we can go ahead and give the decimal approximation for that, which is approximately 12.04. So then my distance between A and B is 12.04 units. And then you're done. So how do we feel about that?
That this is gonna be really hard to do over online.
Well, the good news is you can write it down on paper. You don't have to do it on like a PDF or anything, but I think it'll be okay.
Yeah, still have to take pictures. That takes time.
It does. Okay, are we ready for another example? Sweet. Okay. If I'm moving too fast or you guys need me to slow down, just let me know, please. Okay, so our next example, we're going to be finding the distance between 2 points again. I'm going to have point 1 has the coordinates 3, 6, and point 2 has the coordinates -2, -1. And I would like to find the distance between those 2 points. Just like before, the first thing I'm going to have to do is I'm going to have to graph this. So I have my x-axis, I'm going to plot point 1 first. We always start at the center, which is 0, 0. From there, I'm going to move right 3, and I'm going to move up 6. And that's going to be point 1. Then I'm going to go ahead and plot point 2, which is -2, -1. So from 0, 0, I'm going to move left 2 and down 1. And that's point 2. Just like we did before, I now need to find the horizontal and then the vertical distance it would take for me to get to point 2 to point 1, as if we were walking the blocks of a city. Okay, so we can't cut diagonally across anything, we have to do squares. So from point 2 to point 1, because I find it easiest to work from the bottom point, I need to figure out how far right I would have to go to get in line with point 1. Well, I have to go 1, 2, 3, 4, 5. I would have to go 5 blocks to the right. And then I go ahead and count my vertical distance. So from being on the same line as point 2, I'd go up 1, 2, 3, 4, 5, 6, 7. So I have a vertical distance then of 7. And then we know our end goal is to find this diagonal distance. And the only way I can do that is with our Pythagorean theorem. Again, Pythagorean theorem is a squared plus b squared equals c squared, where c is the unknown I'm trying to solve for. I know a and b because they're the 2 lengths I just found, so 5 and 7. When I plug those in, I get 5 squared plus 7 squared equals c squared. I simplify these. 5 squared is 25. 7 squared is 49. I go ahead and I add 25 and 49 together. When I do that, I get 74 equals c squared. And then I take the square root of both sides. Square root and a square cancel each other out. So I'm left with c equals the square root of 74, which is approximately 8.6. So that means that the distance from point 1 to point 2 is approximately 8.6 units. I will give you guys a second to catch up, and then we'll do another example.
I have a question.
Yeah, what's up, Miguel?
Just because what is it? I initially got 6, so I was like 1 off, and I'm trying to figure out where I like miscounted, or like if I just didn't count like we count all the way up to the point, right? Is that it?
Yes.
Okay, so it's not we don't like count. It's not like that we don't count that part. We just go okay.
Yeah, go all the
Because
way up to the point.
because I think I just counted up to it, and then I didn't count the
Right.
last point. I didn't count the point itself. I didn't count point 1.
That's very common. So yes, make sure you're counting the point because that's when we finally reach it.
Yeah, I wouldn't want to do this like on a PDF, so I'm definitely gonna just write this and take pictures.
Sounds good. I hope that's what all of you do. Okay. Does anybody need me to leave this example up right now? Okay, so I'm going to go ahead and write the next example that we're going to look at. Again, we are finding the distance between 2 points. This time, I have points A and B. Point A is going to be at 4, 3. And point B is going to be at 5, negative 5. Just like before, the first thing I need to do is I need to go ahead and graph this. I'm going to plot point A first. So from 0, 0, I move right 4, and then I move up 3. And that's point A. I do the same thing for point B, but I'm going to move right 5. And then I'm going to move down 5. And that is point B. Give you guys a second to get those graphed. Okay, so I'm going to start with point B and work my way up to point A. So from point B, I like to do my horizontal distance first. So am I going to move left or am I going to move right to get in line with A? Hopefully we recognize that I need to move 1 unit to the left so that I'm in line vertically with A. So this is a distance of 1. We don't have a negative 1 because we can't have a negative distance. So even if we're moving left or if we're moving down, it's still positive. Okay? Then to get in line with A horizontally, I need to go up. So 1, 2, 3, 4, 5, 6, 7, 8. So then I went vertically up 8 units. And I've got my right triangle. She's a little tall and narrow, but she's still a right triangle. So then from here, I'm going to do the same thing I did before with my Pythagorean theorem. So I've got a squared plus b squared equals c squared. C again is what we're solving for. A and b are the two distances that I just calculated. So I'm going to have 1 squared plus 8 squared equals c squared. 1 squared is 1. 8 squared is 64. Put those together and I get 65 is equal to c squared. Just like before, my goal is to get c by itself, so I need to square root both sides. A square root and a square cancel each other out. And I'm left with c is equal to the square root of 65, which, if you put it into a calculator, you're going to get approximately 8.06. So I would say my distance from point A to point B is approximately 8.06 units. Okay. Give you guys a chance to finish writing that, and then we're going to move on to some story type problems, because I know how much you guys like those. Okay, does anybody need more time writing this problem? Okay, so next example, we're gonna have to draw it out first, and then we will go ahead and talk about it. So do 9 on each axis. We're going to say the 0, 0 right here is this person's home. Then at 1, 1 is going to be the school. Then at 2, 3 is going to be the church. The park then is going to be at 2, 5. And then finally, we're going to have the beach way up there at 5, 9. I'm going to go ahead and write the coordinates for you just so you have them in case you are lost. Okay, so then this kind of goes with the story problem. So the story problem is that Karen lives here at home. Okay, she's claiming that the distance from her home to the church is equal to or the same as the distance from the school to the park. So we need to either prove that she is correct or prove that she is wrong. In order to do that, I'm going to have to calculate that diagonal distance from her home to the church and that diagonal distance from the school to the park, and then compare the answers. Okay, so we're going to do home to church first. I'm going to use this, we'll use white to do that one. So I'm only looking at home, which is here at 0, 0, and church, which is at 2, 3. So I need to do the same thing I did with the right triangles before. From home to get on the same level as the church, I had to go up 3 units. Then I need to go horizontally to get to the church, and that means I had to go right 2 units. So I'm going to use that information to calculate this diagonal distance from her home to the church. I'm just going to use Pythagorean theorem like I have been before. So I have 2 squared plus 3 squared equals c squared. 2 squared is 4, 3 squared is 9, which means I get 15 is equal to c squared. To find c then, I'm going to square root both sides. Oh gosh, that's 13, sorry, not 15. I'm going to square root both sides, and I get that c is equal to approximately 3.61. Okay, so that means the distance from her home to the church is 3.61 units. I now get to repeat this process going from the school to the park because that's the other distance I'm going to have to calculate. To make it a little bit easier, I'm going to erase what we have here just so it's not in the way, but you are more than welcome to leave it or to draw another grid. That's your choice. I'm going to use blue for this one. So I'm going from the school to the park. So starting at the school, I have to go up 1, 2, 3, 4 units to get in line with the park. Then to get to the park, I need to move right 1 unit. Using that information, I'm going to go ahead and calculate that diagonal distance using leg lengths 4 and 1. So in my Pythagorean theorem, I'm going to have 4 squared plus 1 squared equals c squared. 4 squared is 16 plus 1 squared, which is 1. I'm going to get 17 equals c squared, which means c equals the square root of 17, which is 4.12. Once I've calculated both distances, I just need to compare them now. So my distance from her home to the church was 3.61, but her distance from the school to the park was 4.12. Are those two numbers exactly the same?
No.
No.
No, which means that she is not correct in her assumption that the distances are the same. So we would say this or prove this by saying 3.61 does not equal 4.12. So we would say she is incorrect, and that is why. And then we're done. We're going to go ahead and do probably just one more example, and that should be enough for you to start your homework. As always, if you have questions, just email me. Okay? So let's do one more example. Hopefully none of you are leaving yet. This is another story problem. So listen up. It says, 2 joggers run 8 miles north and then 5 miles west. What is the shortest distance to the nearest 10th of a mile they must travel to return to their starting point? So let's say that we have a compass. I'm going to be starting in the center. Directionally, I know up is north. I know right is east. I know down is south. And I know left is west. Okay, those are just using our cardinal directions. So it's saying if I started here, I ran 8 miles north, which means I ran 8 units in the upward or northern direction. Okay, so I went up 8. Then after I got 8 miles north, I ran 5 miles west. West is left. Excuse me. So I ran 5 units to the left. Even though I don't necessarily have the ticks on the graph, that doesn't change the fact that I have measurements for these lengths, which means I'm going to use that 8 and that 5 to calculate this diagonal distance here, because it wants to know if I stopped here, what's the shortest distance I would have to run to return to where I started. And that shortest distance is always a straight line. Okay, so we're going to do Pythagorean theorem again. I have 8 squared plus 5 squared equals c squared. 8 squared is 64. 5 squared is 25 equals c squared. 64 and 25 is 89. Square root both sides. And I get c is equal to the square root of 89, which is approximately 9.43 units. So if she stopped 8 miles north and 5 miles west, it would take her approximately 9.43 miles at the shortest to get back to where she started. Okay, so there are some other short problems in here, but I want to give you guys time to look at the homework. So that's the last example we're going to do in class. If you have other questions, please let me know. And I will stay on this Google Meet for the entirety of class in case you have questions. Okay, I hope you guys stay on too, but I can't make you. So look at the homework, test it, ask me if you have questions.